So you look at this, you have static service pools and you have your dynamic um, resource pool configuration, right? And you also has got the utilization report. I think you might have noticed here, utilization report, which gives the cluster utilization report. I think you noticed I renamed this one to dev. It was cluster one earlier. I renamed this to dev and made some changes also to make this more specific. So you see here, total CPU cores you have 24, average utilization, maximum utilization, daily peak and all you have. Here also you have the memory utilization, total physical memory given to all these hosts in the cluster. You have altogether 6, right? I think 12, 12 and remaining and all 12, 12, 24 and remaining 8, 8, 4, 32. 32 plus 24 is 56. Total physical memory and the average utilization, the maximum utilization. So you get the specific to yarn you have. Specific to yarn also we have. What is the CPU utilization and what is the memory utilization? I think you noticed here the pool what is being created. That is also been visible over here. Right? So you can have even if you look at this one, current disk usage by user, current disk usage by user, all these are the users. I think you noticed. All these are the users. Your Hive, Cloudera, Yarn, Root, all these are the users actually. Current disk usage by user. Current disk usage by group, same like you have the historical applications. The historical applications by yarn pool. So all under the reports category. I think you see that here. So we are trying to cover almost all the features that are visible to you as part of this Cloudera manager. So this we are aware what we have here, how you add the service, commission, decommission, and all that stuff. We have seen very clearly. Adding a new service, stopping that one, restarting that, making the changes. When you have some stale configurations, why you need to restart that particular service. And when you're restarting the service, how the dependent service also needs to get restarted. So all that we have seen. So as part of that, we are seeing the static service pools and the dynamic service pools, host reports, utilization report, your Impala queries and yarn applications. Why specifically you have Impala queries here? Why specifically we have this? And we also notice there is a daemon running on every host. And when it comes to the Hive, I'm saying It is same like your Hive only. But why you have specifically Impala queries when it comes to the cluster? Even everywhere, I think you might be noticing yarn you are separate, overview you are getting in here, overview you are getting, CPU utilization and the memory utilization. But specifically we have yarn and Impala and the utilization report. Why? Anything specific? Anything specific, friends?
Could it be because you want to run some custom queries against the cluster for some performance purposes?
Yeah. So for example, email survey options. So some existing thing only we have. You notice you got some output here. We'll see about this one. But we got some output here. What is that? Because I logged in with Cloudera. I think you remember that. And we have specifically both Yarn and Impala we have. In the cluster overview, if you see, we have both Yarn and Impala. But specifically when you see here, database is default. I think this is from customers only, right? Yes. You noticed that customers only. Exactly a minute before, I think you noticed here. 9/5/2017, 6:17 a.m. User Cloudera. So this is what we are doing. Of course, from the Hive browser we have that. That's a different story. We are running that one from the Hive browser only, whatever the query. But that we could see very clearly from the Cloudera manager 3 minutes ago. The customers table from the sample database. So we could see that very clearly here, whether it is successful or not. All those details we are able to get, the charts and all for that. Average peak memory usage and your duration, your HDFS bytes read. It's a very small table. That is why you don't have much impact on the cluster. It's a very small table. It's not a very big one. So you don't have much impact for this. So is for the reason Impala is been specifically dealt for the reason you see closely here. It's going to make use of CPU when you have is going to be. It's going to make use of memory resources compared to that of your Hive because you do in-memory computing. So you do in-memory computing. So Impala is going to make use of your cluster resources different than your Hive. That is the reason why it is being separately dealt. That is where peak memory usage, the spilled memory in the context of Impala, but not in the context of your Hive. That is why for the cluster utilization, we are going to see the usage of the resources by the Impala daemons that are available on every, I don't know whether you notice that or not, we have a Impala daemon running on every host, Impala daemon. You noticed? You have your Impala daemon. And here also you have Impala state store and you have Impala daemons running on 4 hosts inside this cluster. All the 4 hosts. That's how we have set up. On 4 hosts. Yes, Impala daemon on these 4 hosts. On 4 data nodes. So that is why it has been specifically, when it comes to the resources, it has been specifically dealt. That is where even here also Impala queries and yarn applications. Impala queries right away. Right, in terms of this resource allocation also, we take Impala separately into consideration. Right, so which you can see from the HDFS from the reports perspective also. MR jobs and Impala. Historical queries by Impala pool. The historical queries by the user. Only one, I think you noticed.
So the Impala query goes against the Hive tables, is it?
Exactly.
But when I have Hive running, why would I use Impala?
For efficient querying, Arun. For efficient querying. See, database is going to be the same. Database is going to be the same. We don't have separate database here. I think you noticed. It is the same warehouse you have. We don't have separate warehouse here. I think you noticed. You go to this Impala or Hive. You don't have
So Impala is basically easier than Hive SQL. Is that what it is?
no. Everything is the same. Only thing is, in terms of the query execution only, there is a difference. The background execution process. Only in terms of that there is a difference. Rest of all it is the same. You see here Hive, the default database inside that you have 4 tables, right? Even you go to your Impala, you have the same database. Impala and Hive has got the same database. But the way the queries gets executed in the background, different. The same 4 databases, the same 4 tables only inside the default database. I think you noticed here.
So Impala also submits MapReduce jobs in the backend, right?
No, Impala is not going to make use MapReduce. That's where the difference comes.
Oh, okay.
That is where the difference comes actually. See, if it is the same MapReduce, then definitely it's going to make use of the same yarn, right? Because it is a yarn-based cluster. You understand the point here, Arun?
No, I'm getting confused. Why would one use Impala compared to Hive if it is going against the same databases and tables? What is it that is differentiating?
Because Impala, the way that it is going to process the data is different from that of your Hive. It is going to make use of in-memory computing. That is the reason why it makes use of a lot of resources.
So it's going to be faster than your Hive queries then?
Yeah, absolutely. Absolutely. On huge data sets, that is the reason why, if you see closely, same warehouse, same everything, but if you query the data from maybe these small tables and all, I don't think you see, because there will be the job execution, I mean initiation and the termination overhead will be the same. So as a result of that, we will not be able to see much difference in terms of the execution. But if you observe closely, that is where even at the cluster level, we have the difference. Everywhere we have that different. Suppose if it is the same MapReduce that is running in the background, then it's going to make use of yarn only. It's not going to be different, right, Arun?
So if it is a huge data set, right? If the data set is really big, so what you're saying is Impala is not going to be doing MapReduce jobs in the backend, right? So does it mean it is not going to do any parallelization when I run the query?
Now you do parallelization, but for that sake it makes use of, see, the technique is the same, but where that is getting executed is different. So I tell you like this. I think maybe others, I think Mani and Anne may not be able to get that point precisely, but you know the job MapReduce job life cycle. So you look at that one closely. So if you look closely into the MapReduce job life cycle, after every phase, what are the phases that you have as part basically? This is a whole big story. That is where the performance tuning, of course, the very immediate thing which we are going to talk, performance tuning, there also we come across the same. As part of your MapReduce job execution, if you see closely, you have a mapper phase, and then we have something called a combiner phase, and then we have something called partitioner phase, and then we have something called shuffle and sort phase, and then finally we have something called reduce phase. And overall we call this as a MapReduce programming model, which is a backbone for your entire Hadoop ecosystem. For your entire Hadoop ecosystem, I mean, on the top of your HDFS, we have the processing layer called MapReduce, which I told you number of times. And on the top of this, you have data access layer. What we have in the data access layer, Pig, Hive, Scoop, and all as part of your data access layer. So this is my storage. This is my processing. And this is my access. And what is the top of this one? Management, using your Zookeeper and all. On the top, you have something called data analytics. See, the ultimate goal is analytics only. But for that sake, where we are starting with storage, then we are thinking about processing, then we are thinking about access, then we are thinking about management, and finally you reach the level of analytics. So let you run a Pig script or a Hive query or anything, let it do anything, but ultimately it is been grilled down to MapReduce only. Let it be Hive query or a Pig script or whatever it is, it grills down to MapReduce only. So when MapReduce is the backbone, the problem is on one particular node or host, we have multiple mappers running. Only when the map phase has been finished, we'll go to the combiner phase. Now, till then, this data, the output of your mapper phase, is spilled or stored to the local disk. This is the biggest setback. I don't say it is based on this one, I claim that, MapReduce is gone and all. That is the only way we have. So where the data needs to be stored temporarily, till the next phase is going to be initiated, where the data needs to be stored, it needs to be stored on the local file system. Local file system, I mean, where your MapReduce job is getting executed, on which host it is getting executed, on that host, the data is going to be spilled. And that is being read by your combiner, and it is going to spill to the local file system again till it is going to be read by the partitioner. Now the thing is, because of this local, writing the data to the local file system and reading it from there, the IO that is being, the IO, this is a most crucial thing, IO. This is going to take a lot of time. And you know very well, in terms of the cluster, how precious is this time. Suppose if this writing the data to the local file system, reading from there, writing, reading from there, writing, reading from there, if that is being avoided, obviously the performance of your job is going to be increased tremendously. Now, for your Hive, the background is MapReduce. I'm saying for your Impala, the background is a MapReduce kind of thing. MapReduce kind of thing. I mean, massive parallelism is the backbone. Massive parallel processing is a backbone, but not your MapReduce where your local disk writing will not be there. That all happens. Whatever you are writing to the local file system, that is being avoided because the data is going to be stored in the primary memory itself. So between MapReduce and Spark, you have something called Impala. Spark didn't came just like that straight away from MapReduce. In between we have Impala also, which most of the times people don't consider or don't look into that. Because Impala is also going to make use of. That is the reason why it demands huge cluster resources. You got the point, Arun?
Yeah, so what you're saying is it is not as efficient as Spark, but it is more efficient compared to MapReduce.
Absolutely.
Right? That's what it is.
Absolutely. That is the reason why we have that separately. When you come to the reports or when you see anything, why specifically, if it is the same Hive kind of execution, then we will not have separately Impala queries here, right? Because you see here MR2, that is MapReduce included in the yarn, MR2 jobs. So we'll have the same, even Hive and all you run it, it will not have, it will not be treated separately. It will not be treated separately. You can see that from the same, you go to this.
So Impala also has a command line interface like Hive, or is it all GUI based?
No, come out again.
Does Impala have a command line interface like Hive? In Hive, you can open that terminal and then you can type Hive and then you can write your queries, right?
No, no,
Impala
no.
also has a similar thing?
No, no. That we can do it only from this GUI.
Oh, okay.
Actually, initially it was a proprietary of I don't know whether it is been made open source or not, to my knowledge. No, I believe. You'll see this one only as part of your Cloudera. Maybe now I'm not sure, but I don't see this as part of Apache. Maybe some license they might have released, but otherwise this is actually been developed by Cloudera only. This is not a part of Apache. Impala is not a part of Apache. You see the other one. I think you noticed that. They are not this one. Where we did that in Impala only. Okay. what is that?
So can you write your own functions like we used to do in Hive, where you write a Java code? Can you write such functions in Impala to be
Yeah.
used by Impala?
Usage is the same. Usage is the same, and functions, how you write, everything is the same. No difference in terms of that. The only thing is, in terms of the execution in the background, that is the only difference. How this is going to be executed in the background. That is the only difference that arises, Arun. Here, let me show you that historical queries by on historical queries we see. It's not getting refreshed. One second. It's already been done. It's not getting refreshed here actually. It's already been done. You see this the queries that are being executed. These two are already been done. The two queries what we executed 6 minutes ago and 27 minutes ago. Let me run a different one. There is a problem here getting refreshed actually. The earlier one is gone. It's showing these two, but it has already been executed. There is no problem in terms of any health related issues. No health issues and time issues here. That is also gone. But don't know why this is still showing executing. This is over actually. You notice that this one which we executed some time back, that is over actually. 6:17 a.m. These are the recent queries. 6:38 and all, these are the recent queries. 6:44, these are the recent queries. And I think you noticed here. Average peak memory usage, the aggregate peak memory usage. But still this is showing, because here there is no query result available for this. You want, you can go there and see. The result also still available. You can see that in the chart form also if the result is available. Let us see. Still it is showing. Estimated per host requirements 48 MB, virtual course 1. See here the Impala, but it is working on the same, the session type is Hive server only. Query type queries, query state created, and that is admitted immediately. And connected user is Cloudera. File formats is Paraquat. This I mentioned it some time back. HDFS average scan range. You can see it, read throughput. Node with peak memory usage is data node 3. Out of memory false. So everything is as expected, but still I don't know why It is showing still it is in under execution. That is already over. Even the health status of this one is pretty good. No problem for that. There is some issue here. I don't know what is that, because this is already done. The execution has already been done. There is no query pending here. Even you can see that here the result of that is available. ID, name, email preferences from customer C. So I think you see here, select ID, name, email preferences from customer C. You notice that one here?
Yeah.
But still, because the result is also available here. So usually what happens after the query has been executed, the results are going to be retained for some time. I think you noticed that one. In the query history, you take this one, what all the queries that are being executed, the results have expired. Rerun the query if needed. But if you see this one, for this customers, the data is available for that. The result is available. But it is showing executing, still it is executing. Maybe that executing reflects as the data is being still cached by the Impala daemons. The data is still cached by the Impala daemons. That is why it might be showing executing, but it is over. Data execution, I mean, the query execution is over. The same query. Select ID, name, and email preferences from customers. You see here, select ID, name, where you have the I think you see that here. Right? Is it that execute the next statement is also there? That is the reason why it is still showing? Might be. Yeah, I think yes. As we have the other queries also in the same, that might be the reason. Yes, I believe. Let us see now. All the three queries been over here. I think this also will be over in a while. This also will be over in a while. I think as we have three queries in the same script that we have, that might be the reason why it is showing still executing. But for sure there is a difference in terms of the refresh rate here. You're not getting immediately updated. Let us see this here. This is over 3 of 3 over. What is the last query here? Select c.id as customer ID, name as customer name. See orders, select sum of price into quantity from this was some query. Okay, no problem. So I think the same query here. The same query, yes. Query plan, everything is fine. That is fine. Don't understand still, it is showing executing. But that is OR actually. 3 of 3 queries been OR. Where it is still holding that let us wait and see, is it going to be released from here or not. But out of the 3 queries that are there as part of the same script, all 3 been executed. I don't know why still it is showing. All 3 been executed. I think you noticed here 3 of 3 showing the result of the statement 3 with the same script. I think different you are seeing. The same we are doing it once again. See, all these are the queries that we executed now, just now, in today's session only. All these are the queries from the same. But why this query is been still held up? That's where I don't understand. The second one is over 2 of 3, and the third one But if you see closely, it will not be executing these things. I think you noticed here. It is not executing these things repeatedly. The data for these queries, for this one, is readily available. You can go and see that one. ID, comma, customer name, order ID, total. You are able to see this one without running that again. You are not running because results are available for this. And over a period of time, this will be out. Let us wait for some time and see, and then come back to this one and see. Is there any relationship that exists till the results are available here? It is going to show that the query in execution. Is that true or not? We will see. Let us leave this one for some time, and then we come to know whether it is caching those results. As a result of that one, in the Impala query section, there is one query that is showing getting executed, but there is nothing that is getting executed here. It's all done. It's all done from here. But you notice that there is one query where the result is available, not the results of the other queries that we executed. I think you noticed. So let us leave this one, and then we come back to this to continue the discussion on it. So Impala, as it is going to use a different mechanism in the background, I mean, it makes use of CPU and even CPU anyhow definitely going to be, but more memory resources, which is going to avoid the spilling of the data to the local disk during its execution. It's going to make use of more memory resources. And that is the reason why you have that Impala daemon that is present on all the nodes, which is going to consume the resources, basically the memory resources during the execution of the queries. That is why it is been separately dealt along with yarn. It is been separately dealt along with yarn in terms of the cluster resource utilization, right? So we have also observed the reports. As part of the reports, you can see the current disk usage by user, by group, even in terms of the MapReduce applications. I mean, that is yarn-based MapReduce applications. You see very clearly here, and the Impala queries also you see. You can get the reports, and those can be even exported in the way you want. You can download those reports in the XLS format or CSV format, right? So here, as part of this cluster, host reports, utilization report, Impala queries, yarn applications, static service pools, and the dynamic service pools. I think we have seen all the options that are available as part of this, not leaving anything, right? Arun?
Yeah, got it.
Let us go there and see once again. Okay. Still the result is available. Fine. Let us leave that one for some time and come back there. Yeah. So coming to the performance tuning of the various resources on the cluster, we have seen a few in the past. How I/O can be improved. Okay, we revisit those things again. Hope this the concept of pagination is aware to you. the concept of pagination.
Yeah, paging is storing it in memory, right? How much memory you're giving each time the output goes, and then it is returned to the disk.
Now come out again. Come out again. How much memory?
It is temporarily returned to memory, and then after the memory gets filled, whatever is that, it is returned to the disk.
No, I think, right? See, pagination is a kind of concept at the operating system that the process which are not active, are being sent to the secondary storage, and whenever they are going to be active, we bring those things back from the secondary storage to the primary storage. So that process is what we call it to be pagination at the operating system level. So truly speaking, all the process, that is why we call it as a process, otherwise we call it as an application. Process and application are the two terms we have, or we call sometimes as program. So this is a code which is at rest. Code at rest is what we call it to be a program or an application. When the same program or application is given the resources to get executed, we call that as a process. So the moment I use a term called process, I am talking essentially in the context of RAM only. The program is running. But what happens in the RAM, if a program is not active for some time, then that program is being persisted to the external storage. Is being persisted to the external storage. I mean your secondary storage, your hard disk drive. And when it is required, we bring back that from this one. The frequent we do this, there will be an impact in terms of your, I don't know what to say, maybe in terms of the accessibility or in terms of the performance. Definitely there will be impact, because the temporary persistence is going to kill the efficiency of the execution. The temporary persistence, you are persisting this process. When you are persisting the process to the external storage, definitely all the state when that is running, what is the next executable instruction and what values are stored inside your CPU registers, including the precise minute details, all needs to be persisted to the external storage. When you are loading, you load all those details back into your active memory. So the frequent pagination, persisting these things to external storage and bringing them back live and again persisting, is going to kill the efficiency. The same when it comes to this one, you see here, most Linux platforms supported by CDH5 include a feature called transparent huge page compaction, which interacts poorly with Hadoop workloads and can seriously degrade the performance. Most Linux platforms supported by CDH5 include a feature called transparent huge page compaction. What is this huge page compaction is what we have discussed till now. You can have a look at that. When a process uses some memory, the CPU is marking the RAM as used by the process. For efficiency, the CPU allocates the RAM by chunks of 4 KB bytes. I think you are getting the point what I am trying to specify here. Since the process address space are virtual, the CPU and the operating system has to remember which page belongs to which process. I think you noticed here. Those chunks are named as pages. Which chunks? Your 4 KB, your 4 kilobytes chunks are technically called as the pages. Those pages can be swapped to the disk. Those pages can be swapped to the disk. But you see, these 4 KB pages that needs to get swapped is going to be very expensive process. That is the reason why instead of 4 KB, we are going to increase this one in the case of big process. That is where we technically call them as huge pages. You can see that here. Most current CPU architectures support bigger pages. Those are named as huge pages. Super pages or even large pages. I mean, depending on the operating system, we use a different technical term, but all reflects the same. The transparent huge pages are enabled by default in your Red Hat Enterprise Linux 6 for all applications. So as a result, your Hadoop application execution is going to be impacted very badly. Are you getting this point, friends?
So basically, the page size is more than 4 kilobytes, right? It's a huge page. I think it is 2 megabytes. That's what it's saying.
Exactly.
When you implement the huge page.
I mean, it is a page concept only, but we use specifically the term called huge page for the reason the pages that are being allocated as they are too small. The same story. We were talking about the name node and all the times. See, your Hadoop cluster is basically meant for relatively small number of huge files than small files of more in number, right? Because each file metadata is expected to be persisted by the name node, and every million blocks, this much memory is needed for the name node. When the number of blocks gets increased, I mean, number of blocks gets increased, we require more resources. Number of files gets increased, also we require more resources. But number of files increases, small files, huge in number, is going to impact the performance of your name node. Same like even here, when the page size is small, when it needs to be persisted and it needs to be retrieved back, is going to be more expensive. That is the reason why we are interested to increase the size of this page. I mean, it is the same old story. No, instead of, because it is all been dealt in the form of pages. At your memory level, it is in the form of blocks. I don't know whether you remember this or not. While dealing the file system concept, I dealt this one. If the block size, your entire hard drive storage is divided uniformly into blocks. Okay. If this block size is too high, then we may be losing memory, more memory. And if this block size is too less, there will be more blocks per file, and that is also going to increase the load. So it should be always optimal, right? As today's process are not small process like how it was a decade or 2 decades before. So this concept of a page where the size of the page limited to 4 KB, if that is been increased, then its maintenance is going to be in the control. I think you remember, you understand this point. The CPU allocates RAM by chunks of 4 KB bytes. This is at the RAM level. Same at your hard disk level also, we call it as blocks. Concept is the same, no difference. Okay, those chunks are named pages. Those pages can be swapped to the disks. So the process which are not active, those need to be persisted to your secondary storage. And if this is happening frequently, the performance is going to hit. That is the reason why this transparent huge page compaction should be disabled. You are getting my point here, friends?
So Srini, I'm a little confused. So what you're basically saying is don't go for a big page size, right?
No. That is okay. But this frequent pagination, I mean pagination in the sense like persisting these things to the memory and bringing it back, is going to kill the efficiency of your job execution, right?
Yeah, so you want everything to be residing in memory, right? Suppose you have a large number of files in the name node. You want all those
No, no, not name node, not name node. This is all.
the metadata of the files.
No, that is anyhow going to be in the memory only. Your as far as your name node is concerned, that is absolutely fine. Don't bring that into this context. This is all in the context of your job execution. These are in the context of job execution. Okay, fine. Look at this one here. The transparent huge pages are enabled by default in Red Hat 6 for all applications. For all applications, I mean, for all applications, I mean,
You mean like Hive, Scoop, whatever is application that is running on that?
right? Because ultimately they are getting executed at your host level only, right? They are not getting executed at the central level, right? I think you agree with my point. So this transparent huge page feature at your host kernel level is also applicable to the tasks running on that host. You agree with me? Yes or no?
Yes.
Look at this one. So this is by default kept in the enable mode always. Red Hat transparent huge page is by default kept in the enable mode. So as a result, what happens? As a result, what happens?
So it assigns bigger pages in memory.
No,
The page size in memory is large.
Yeah, that is true, Arun. That is true. I agree with you, and I am with you on that. But thing is, the kernel attempts to allocate huge pages whenever possible, and any Linux process will receive 2 MB pace. So as a result of this one, what happens is, the pagination will happen. Whenever there is a pagination happening in the beneath layers, persisting this process to the external storage and bringing it back is going to happen in the beneath layers. This process is going to kill the efficiency of your job execution. That is what the point you need to identify here. Suppose if this pagination concept is disabled, then what is going to happen? These inactive process will not be persisted to your secondary storage. As a result, the performance of your job execution will be improved. That is a point you need to identify and understand here. In which context we are talking? We are talking in the context of your MapReduce job execution. And that is the reason why I used to say number of times. Now this is purely whatever I'm talking now, this is purely the admin job. But how come you understand the concept behind this one? You can understand this concept only when you understand the life cycle of your MapReduce job. I think you notice here, on a single host, till all the mappers are going to finish the execution, the combiner phase will not be started, the partitioner will not be started, till all the partitioners are going to finish the execution on all the hosts, the shuffle and sort phase will not be initiated at all. Till the shuffle and sort is going to finish, the reduced phases will not be initiated on different nodes. All these are the phases dependent on the earlier phase for the current execution. Now, when your map tasks are running, on a particular host, this is what the host you have, and there are 4 map tasks functioning, out of which 3 are already been executed, that is been done, and the 4th one is running now. As these 3 are not getting executed, I mean these 3 are inactive. Suppose if these 3 processes are persisted to the hard drive, and when they are required, again you bring them back to the active state, that swapping from main memory to your hard drive and the hard drive to your main memory, that is going to consume the time, right? And that is going to kill the efficiency of your job execution. I think now you got the point what I'm trying to share with you here.
Yeah, so if I say pagination is 0, which means everything is going to be in the RAM.
Yes.
But there is a limit, right? I mean, my RAM is fixed. I cannot, there should be some limit, right? I mean, it cannot accommodate everything.
Yes. Because when we are talking in the context of here, when we are talking in the context of big data, I don't know whether that if possible I try to show that one to you. Yes.
So if I set pagination to 0 and if the RAM is totally filled, what happens? Does it crash?
Why it crash? Because according to the job execution philosophy of your MapReduce or Yarn, it is going to run on the other nodes. Why it is going to crash? See, what is the ultimate? No, what is the ultimate goal of all these hosts? Say you have your Hadoop cluster. You have your Hadoop cluster of size 10. Every host that is a part of this Hadoop cluster, what is the basic purpose? What is the basic theme? To run your Hadoop jobs only, right? Or any other task you have. All the nodes you have in the Hadoop cluster, do you have any other task for these hosts other than running the Hadoop jobs? Let it be MapReduce or some other, whatever it is. Hadoop jobs, right? No other thing.
Yeah.
But if you take a normal machine, here you may have 100 requirements. But here if you see, the only goal of all these hosts, all the times, 24/7, 365 days, you expect Hadoop jobs to run on this one. No other work. These are dedicated for that one only. Right? Now, when a particular node where we are compelled to run 4 tasks. Suppose if memory is not available there, this task is going to be executed on some other node where that block is present or in that input split is present, because you have the replication factor of 3. I need not execute that one only on this host. I can execute on the other host also, because the same block is available to me on 2 other nodes. You are getting the point. This kind of allocation and this kind of execution is all being taken care by your job tracker and your resource manager. We need not worry for that one. Who is taking care of that? Your job tracker or the resource manager is taking care of that one. So why we are worried? We are only worried whether your job is getting executed. And I also told, because this is all related to the development front, but still as we need to understand this one, we are discussing this concept. So there is something called speculative execution at your job level. What is that one? Say if some task is taking more time than expected, same task is also going to be executed on the same block on a different node, and if this finishes execution, this is discarded, the result of this execution is being used. Who takes care of that? We are not worried. We are only worried about submitting the job to the cluster. That's it. And that speculative execution needs to be enabled. With our property, we need to just intimate to the cluster that enable the speculative execution for this job. That's it. And taking care of running a task which is taking more time on a different node out of the 2 same tasks which are running on the same split, which is going to finish first, that is going to be taken, the other one is discarded. So speculative execution is also being taken care by your job tracker or your resource manager on it. So we are not worried. You are getting my point?
Yeah, got it.
So because of disabling this pagination at your you mentioned, you raised a very valid point, but because of disabling this feature at your kernel level, at your operating system level, so there is no problem to me. Why there is no problem? Because the core goal of each host inside the cluster is to run the MapReduce jobs only, no other goal. If certain tasks are not able to be accommodated on that particular host, no problem. The resource manager or the job tracker is going to ensure that the same split is going to be processed on a different node. Same split is available at 2 other places, right? So it is going to be processed in the other node, no problem to me. So my processing will not be impacted if there is no memory. But by disabling this one, the swapping that we are doing from main memory to your, see, we are only talking in the context of swapping, but the swapping is just nothing but your IO. Writing to the disk, reading. This is writing and reading. So one writing and one reading, if you are able to avoid, that is to your external storage, I mean secondary storage, that is your hard disk drive. See, within your main memory, writing and reading is okay. It's not that expensive. Between main memory and the secondary memory, writing and reading going to be very, very expensive. So if that is been avoided, the job execution happens. The job execution is going to happen pretty fast. You got the point? One second.
Yeah, got it.
Yeah, sorry friends. So I think this point is clear to you. You have any questions on this one? Please let me know. We'll discuss that and close this one here. Mani, Anne, you have any question on this one regarding this feature, transparent huge page compaction? Okay, that's great. That's great. See, it's simple. It's because as I've shown you, this feature is by default enabled on your operating system. So as this feature is enabled, the jobs that are running on that particular host, let it be your own jobs or the jobs initiated by the Hadoop cluster, or the submission of the jobs by the user, as a result the task getting executed on individual host, whatever it is, ultimately any job or a process that is getting executed on your host will be impacted because of this feature enabled on your host. Okay, see, though this is what the point that you need to understand, friends. Here we have two things: one, storage, and the other one is processing. See, your storage is happening at the user space. That is what we technically call it to be fuse, file system in user space. This is fine. This is absolutely acceptable. If you take out that particular host, this is a host as part of your cluster, and if you take this host out of the cluster, this works as a normal CentOS box. The HDFS file system that is being erected on this particular host will not be visible if you take out that machine from the cluster, but that is related to storage. Processing, see, storage ultimately is on your HDD and memory only. Memory, I mean your main memory. Processing is your CPU. See, ultimately this host has got hard disk drives, your memory and your CPU common to your local tasks or your Hadoop cluster related things. Let it be anything, resources are the same resources. Whether your storage is happening on the file system attached to the kernel or your storage is happening in the user space is different, but ultimately it is the same hard disk, it is the same memory that is being used, and it is the same CPU that is being used. So when you are using the CPU, I mean your processing, when you are using the processing, it is all the kernel capabilities that you are using, the kernel capabilities. If you see that closely, if this feature is being enabled, then what is going to happen is the swapping between your main memory and your hard disk is going to happen by default. Let it be a Hadoop process or the user defined process that is working on your host. Let the process be anything. The feature that is enabled at your kernel level is applicable to everything. So as a result, what happens? The performance will degrade. In order to keep up this performance, this feature needs to be disabled. This feature needs to be disabled. If this feature is being disabled, then all the pages will be, all the chunks of memory allocated to the process will be retained inside your main memory. As a result, the performance is being optimally maintained. So hope you have understood this concept very clearly. Disabling transparent huge pagination, huge page compaction. Now I think you understand one point here, friends. I told this thing sometime back. You need to make a customized CentOS and keep it ready. The same customized CentOS is being deployed on every host. Now I think you understand, friends. Even this huge page, the transparent huge page compaction, that is been disabled. That feature is disabled. So we customize the operating system like that, and that customized operating system is deployed onto every host. I think you got my point. So we are not going to do this one on everything. Of course, if you run a script that is going to make sure on all the hosts it is been done, but customizing the operating system as per your need will ease your process, right? If you forget this one, to disable this on a particular host, again the impact will happen. Again the impact will happen at the job level. So that is why, so better you customize your operating system and the same is been deployed to every host. Make sense? Fine. So you also see this one here. Yeah. Yes. There is something called, I mean, this all is related to your, the fine tuning is all related to your MapReduce and your yarn related stuff only. So if you see, MapReduce has got, MapReduce job has got the life cycle. As a part of that, you have shuffle and sort mechanism, what is been mentioned by me here. Shuffle and sort mechanism. I think somewhere, yes, here. You have the shuffle and sort. See, till this level, you see the mapper part, the combiner part, and the partitioner part, this all is within the host. This all is within the host. But you see, this shuffle and sort is going to happen across the cluster. Across the cluster. This is going to happen across the cluster. I mean, for the entire job that is getting executed at your cluster level, there will be a single source for this shuffling and sorting the data and then distributing to the respective reducers. So there is a possibility of improving the performance. The MapReduce, the shuffle handler, yes, the MapReduce, shuffle handler and iFile reader use native Linux calls on the Linux systems with Hadoop native libraries installed. You can improve the MapReduce shuffle handler performance by enabling shuffling read ahead. This causes the task tracker or the node manager to prefetch map output before sending it over to the socket to the reducer. I think you are getting the point here what I am sharing, friends. You can improve the MapReduce shuffle handler performance. Shuffle handler performance by enabling the shuffle read ahead. This causes the task tracker or the node manager to prefetch map output before sending it over the socket to the reducer. To enable this feature, we need not do anything, and this property needs to be set to true. Adjust the value to further tune this one. Anyhow, this feature is by default true only because they know very well that this feature is needed. That is why they kept it true. But to further tune the performance, the value of this read ahead bytes, the default is 4 MB, you make it a bigger one. Are you getting my point here, friends? See, this all is at your job level. This all is at your job level, because performance tuning we can only do in terms of the execution only. Performance tuning can be done only in terms of the execution. How you can make your jobs to get executed fast. How you can make your jobs to get executed fast. So as part of that only, we are now trying to see how different phases of MapReduce can be made more efficient, so that small contributions at every level going to impact your overall job execution. You're getting this point, friends? MapReduce.shuffle.manage.os.cache is set to true. By default, anyhow, it is true only. And its value, MapReduce.shuffle.readahead.bytes. The default value is 4 MB. And you can, if you make it a bigger one, then the performance is going to be increased. Yeah. Someone trying to say something? Yeah, someone saying something, friends?
No, Srini, nothing.
Yeah. So same is the thing. Enabling iFile read ahead increases the performance of merge operations, because you need to understand here, friends, that is your MapReduce shuffle mechanism is going to make use of, this is important here, native Linux calls. So with this you need to understand, though you are working at your Hadoop level and you have separate process, you have everything been set up from your end, but ultimately you must take if there is no touch point between your actual kernel and the things happening at your cluster level, if there is no touch point, if there is no connectivity, how your hardware resources can be utilized by your cluster, can be utilized by your daemons that are running at your cluster level. So definitely the touch point is needed. That is where now you are seeing the MapReduce shuffle handler and iFile reader use native Linux calls. Of course, with the help of the native Hadoop libraries that are being installed, through that only we are going to use these native Linux calls, may not be directly calling them. So that is all to keep things in the control. But how to improve the performance at your execution level, they have mentioned it here. And you may ask me one thing, Srinivas, when they know that this is going to improve, why they can't make it on their own? And why the choice needs to be given? Because we don't know the level of resources with which you are building your host. Your host may be a 8 GB RAM host with hardly one CPU with 4 cores inside, and you have limited storage, or you may go with a very high-end host. So we never know that. Depending on the ability of the resources, you need to make sure that these properties are being set so that the performance is going to be improved. Same is the thing. Same is the thing even with the concept of your iFile reader. These properties need to be set to true, and the respective value needs to be increased so that the performance is going to be increased. It makes sense? And where you do all these things? You do all these things as part of your mapred-site.xml file at your cluster level. Mapred-site.xml, that is one way. The other way is, along with your job submission, you can also set these properties and execute the job. That is also possible. But as this is needed to every MapReduce job, no point that you submit these properties along with your job. That is why you are going to fix these things at your cluster level. Got the point, friends? So like this, there are a couple of properties which needs to be set so that your your performance at your job execution level can be increased. All these are linked with your MapReduce job execution at your cluster level. Because performance, what do you mean by performance at your cluster level? What do you mean by performance at your cluster level?
It's a processing speed.
Absolutely. We have only two things at your cluster. We have storage and we have processing. See, storage is completely with your HDFS and processing is through your MapReduce or yarn. So your storage is going to be, with the replication factor and all those things what are being set, they are being fine-tuned. This is only a one time. This is only a one time. But when it comes to the processing, we run different jobs in different contexts, and we need to make sure that the CPU resources and your memory resources. See, storage I am talking in the context of HDD, not in terms of my main memory. My main memory comes again only in the context of processing. My main memory comes in the context of processing. So that is why when I say resources, I am essentially talking in terms of my main memory and my CPU, not my hard disk. This is done at one time at your HDFS level, that is all. And all the remaining times on the cluster, we only talk about the main memory and the CPU. And those things comes into picture only during your processing. I hope you understand what I am trying to share with you here. So that is why these properties, whatever been mentioned here, these properties are going to influence the execution of your MapReduce jobs. What are the properties that are being mentioned here? These properties are going to influence, and there is one more thing also here. You can see that here. Use a distributed cache to transfer the MapReduce job ZAR file. And again, if I talk this one, you may think that we are going to the development front. That is why I used to say every time, see, there is no absolute administration in Hadoop and absolute development in Hadoop. As an admin, you need to have at least 20, 25% or 30% of development knowledge. As an admin, as a developer, you need to know at least 20 to 30% of admin knowledge, without which you will not be able to sustain at the workplace. So that is the reason why we are compelled to discuss. That is why I am not focusing much, because some of you may feel, oh, I am talking something which is not relevant. People who has got some knowledge on MapReduce job execution can definitely understand what we mean by these properties and how these properties are going to influence the execution of your MapReduce job, right? And these properties, even as an admin, without having much knowledge on the execution front of your MapReduce, if these properties are being set and the values to those properties are being increased, how they are going to improve the performance, that if you are able to understand, we are done. So don't worry beyond that. So even you see here, distributed cache to transfer the job ZAR file. So whenever you submit a job, you submit a job to your job tracker, what happens is the same ZAR file that you are submitting to the job tracker is going to be sent to all the nodes where your respective blocks for the given input path are located. So say for example, the same ZAR may need to be transported to 30 different nodes. Then in that case, my distributed cache option is going to improve the performance of my job execution. How I can do that one? At the job level itself, at the job level, jobconf.setZar and jobconf.setZar by class methods are going to improve the efficiency of your job execution. To add the ZARs to the class path, you can also make use of this one. Use -libzars, and there you can specify what are the libraries that needs to be cached. All those libraries will be cached so that the performance of the job can be improved. See, all these are small things. At each and every level, we are trying to improve the performance, which contributes to the overall execution of your MapReduce job. See, just with the distributed cache, you will not be able to see tremendous difference. You see only small difference, but all these small things put together gives you the performance to your job execution. Getting my point, friends? Getting my point, friends, here?
Yes, Srinivas.
Yeah. So then coming to your tuning of your, this is all the tuning at your execution level. And you know very well that when I'm talking about MapReduce, I mean tuning MapReduce is on not only to MapReduce. When I'm running my Hive query, or when I'm running my pig script, or my scoop command, or my Uzi workflow, all these directly or indirectly will lead to the MapReduce only. So if my MapReduce is being tuned properly, all these also going to be get benefited. Your Hive, your pig, your scoop, Uzi, all these components also gets their performance benefit by tuning your MapReduce. So that point you need to keep in the mind. Apart from that, wherever required, we can also fine tune your respective services. So one such thing we are seeing now, which is important and which is needed, is your fine tuning of your Hive. So for that sake, have a look at this one, friends. You understand. You want to have, depending on the number of concurrent connections that you expect Hive to undergo, up to 40 concurrent connections. The Cloudera recommends splitting Hive Server 2 into multiple instances and load balancing once you start allocating over 16 GB to your Hive Server 2. This reduces the impact of Java garbage collection on active processing by the service. You can see here, friends, depending on the load on your Hive, see, up to 40 concurrent connections. What is recommended? 12 to 16 GB of alone for that service, friends, which you need to understand here. But if you observe closely, in this case, let us go and see that one once again. Why still that is query failed? Results, saved queries and query history. An hour ago this query got failed. Why the query got failed? Still it is showing executing, but there it is showing query got failed. But we got the result. So I think you noticed here, friends, let me conclude this one, but I'm not sure why this is. Let me look into that one because we have different informations from what we are seeing here and what we are getting at that level. So it is saying query failed, but we got the result there. But if you observe closely here, because of running this one, there is no MapReduce job that got executed. But the same thing, if you see in terms of Hive, let me also show this one and conclude this. Then you will have a better clarity in terms of your, this is a Hive, And let me, yes. I think this is the best and the classical example I can give you to make you to understand, friends. What is the beneath layer for your both Impala and Hive? In the past also we executed, you remember in the past also we executed the queries using Impala, but no job has been initiated. You notice that? Arun, I think this is a very classical thing that you can with which you can understand. For your Hive, what is the backbone? For your Impala, what is the backbone? It is not the MapReduce in the backbone.
So when you run the Hive, you can actually see the job that is being executed. Whereas Impala, you don't see that, right?
Yeah, that is what we noticed here. See, you can see that one here,
Yeah, yeah.
right?
Yeah.
So that is how you can understand, the beneath layers of your Impala execution and your Hive execution. But this is a bit strange. Let me look in that. What is the reason behind it? But I'm sure here, if you see the Impala, it is saying the query got failed. I don't know why it reflects the query got failed. Definitely somewhere our understanding is not appropriate. Okay, let me look into that, and I'll get back to you on that one. Here it says query failed, but we got the results also. If you see, we got the results, in fact. I don't know why it claims that the query got failed, but that's fine. So here it is still showing executing. I don't know. The query type is query. But whereas you see in terms of Hive, the query type is going to be MapReduce. That is what you see here, or the job type is going to be MapReduce. It is going to say. Application type is MapReduce, it shows. Right? So here you see, in terms of your Hive, what is being projected, as part of this Hive service, you have a role called Hive Server 2. And you see the configuration for this one, what memory is being given and all. So this is running as part of your, I think on my, this is running on my, one second. See, my Hive Metastore server is running on master. My Hive Metastore is running on my master. And my Hive Server 2, let me show you. It is running on my, yeah, it is running on my manager. I think you see that here. It is running on my manager. You can go and see even at the roles level where this is running. So the same memory is being used. Now what the Cloudera recommends is, if you have 40 concurrent connections, if you expect 40 concurrent connections to your Hive, then 12 to 16 GB of memory is recommended for your Hive server 2. For what? Not for your entire role or service, alone for your heap size, because this is going to run inside. When you are starting your Hive server 2, you should start your heap with 12 to 16 GB. Your Hive Metastore heap size also is recommended to be 12 to 16 GB if you have 40 concurrent connections. Up to 20 concurrent connections, up to 10 concurrent connections, up to 1 connection, you can see how this is been specified. Getting the point what I am sharing here, friends? But the default heap size with which these are going to be started is going to be 256 MB. That is a default heap size with which we start these services actually, or the roles on the respective hosts. But depending on, you want to fine tune, you want to make your Hive to give the expected performance, this is what the Cloudera is going to recommend. Based on your need, you need to, how many concurrent connections here, not, see at any point of time, 40 different queries going to run from different users. Then you need this level of resources. But if you don't need that level, accordingly it is been trimmed down. You can see that here, up to 20, 10 and 1 connection. Depending on your need, you need to make the respective heap size, not the memory to your role. It is the memory to your heap of the JVM running for that particular role. Able to understand, friends, here? You can see that here. The default heap size of 256 MB for each component is inadequate for production workloads. Maybe at your development front that is fine, but at the production, the default heap size of 256 MB is not at all sufficient. And for that sake, what needs to be considered? These needs to be considered. Then only you are able to make your Hive to give the expected performance. Make sense?
Yes, Srinivas.
Yeah. Then comes is your yarn. I mean, fine tuning your yarn. For that sake, Cloudera itself has provided you one configuration template, one configuration template. You can see that here. Let me show you. By making the changes to this configuration template, I think you see here the yarn configuration, what you have. Okay, by making the changes to this one, say I give 8 GB of memory here and 1 CPU, and it has got 4 cores, that is going to be 4 CPUs, vCPUs, and this is going to be 4 into 3 TB, or maybe I give this as 8 TB of memory, that is or maybe 3 into 3, this is something like 9 TB of memory. By making these changes, you see here, you noticed here what is the, you noticed here in the yarn configuration, coming to your host virtual cores, they specified yarn.scheduler.minimum allocation vcores must be less than or equivalent to yarn node manager. So there are metrics that are being predefined. Based on that, you need to make sure how your cluster configuration needs to be. I mean, what should be the based on the host configuration, how you need to plan. And you also can make the changes here. How much your operating system going to consume, and what are the task overhead, and how much your Cloudera manager agent is going to consume, and the other services going to consume. You enter the values over here, and accordingly it is going to give you. And you also specify what is the cluster size. It is going to give you the respective values that needs to be fixed to make your yarn to perform as expected. And these are the templates that are available with Cloudera, and you need not break your head to understand all these things. So based on the cluster resources and the host resources that we have, and the overheads on each host, you fix up all those values. It is going to give you the performance metrics that needs to be followed to make your yarn to perform as expected. So this has been given. This template has been given for the public usage, and you need not worry for that. Now the same, I increase the resources here, and I make the CPUs also to be 8 and this to be 12 or something like, and then you see you got the point. If yarn scheduler minimum allocation MB is less than 1 GB, containers will likely get killed by yarn. So based on the standard metrics, and the resources that you are allocating or that you are giving to your, this is purely the yarn based. I'm not talking about the MapReduce. Yarn based, because you know very well, yarn works with your, I think you know the architecture of the yarn. It is all based on the containers. So a container is just nothing but, at this point it is only CPU, but they are promising in the coming days they are also going to bring memory and your IO things also into the container concept. So to execute your applications, yarn is going to allocate the containers, and with those containers the execution is going to happen. So depending on the availability of the resources, your resource manager is going to negotiate with the node manager to get the required containers to get that particular job executed. So this template is going to give you the understanding, depending on the host configuration, what are the CPUs that are available. I think you noticed here the change in the CPUs, how it is getting reflected. Because at this stage it is only the CPU oriented. That is the reason why you are seeing that change. I think you see here. By making this to get changed to a level of 16 cores or something of that sort, you will have a better this thing. You can see. And not only that one, the other properties also needs to be changed here. Yarn node manager resource CPU cores, and yes, yarn container configuration, these also needs to be changed. Yarn scheduler maximum allocation, the memory, yarn scheduler increment, how in what at what level this needs to be incremented. Your memory needs to be incremented each time there is more memory required, because every JVM process initiates with some initial heap size. I don't know whether you notice that or not. So Java-X, if you see, there is something called every Java process that you initiate, you will not be generally Java and you run it. You will not be doing that. Maybe for your practice or samples you will be doing that one. But when you are trying to run your process, which are going to run in the background for you as a daemon, you want to make sure that they always start with the initial heap size, and you are going to set the maximum heap size. So what happens is your JVM process starts with whatever you set initially, and if more memory is required, it keeps getting increased to a maximum of this one. So you always start your Java process by using your -x ms -x mx. With these things only you are going to start your Java process. I mean all your daemons that are getting started on your cluster. They never get started with just saying Java and you run the process in the background. We never do that. We are going to set the initial heap size and the maximum heap size so that within this range, depending on the requirement, your heap automatically gets scales up. And beyond that, if something more critical, then it may lead to the out of memory error, and that makes your process to get killed abnormally, and that leads to the termination of that particular daemon in the background. And you are compelled to restart again, understanding what is the error, and by increasing the resources. Make sense, friends?
Yeah, sure.
So please look into this aspect. I mean, with this, we are able to clearly go through at the cluster level. If you see systematically, we have understood how you set up the cluster, and after setting up the cluster, how you add the services, and while adding the services, how you distribute the roles to the different hosts on the cluster, and how you are going to fine-tune those roles or services. And then we have seen very clearly how you allocate the resource pools to make your applications gets executed properly on the cluster, various reports, the utilization of the resources on your cluster, and how your Impala and Yarn. Why specifically we are discussing that one? I've shown you a very classical example. If it is the same Hive, we have the same warehouse, we have the same tables. But with Impala, when you do it, how it is getting executed in the background. With Hive, you noticed very clearly the MapReduce job that is getting executed in the background. One second, friends. So with Impala, what is the background execution, and with your Hive, what is the background execution, we have seen very clearly here. So hope you got the understanding. So this is all about your cluster, and I said very clearly the same Cloudera manager can be configured with multiple clusters. You want, you can say add cluster. I can add one more cluster to the same Cloudera manager. One second, friends. So you can add one more cluster to the same Cloudera manager so that it also can be managed. It also can be managed from the same Cloudera manager. Like how we have a dev cluster now, which we are seeing here. Same like we can have one more cluster which is being managed by the same Cloudera manager. We need not have separate Cloudera managers for that. Right? And we have seen on the host part the roles, templates, and the parcels. This also we have seen it very clearly. I don't think you have any issues in understanding these aspects. Host templates, disk overview, and the parcels. And I told very clearly in what way your parcels are better than your packages. And in terms of parcels, what is advantage? You download the parcel and distribute that one and make it activated on the host so that the same parcel of multiple versions can coexist on the same host without any problem. But when it comes to the package, that is not possible. That is the reason why we work with parcels compared to that of packages. Packages almost gone. Not using that package anymore as part of the cluster, right? So we see how, and even as part of the charts also, I think we have seen how we can create our own dashboard and add charts to the dashboard and see only that. Okay, you look at that dashboard, this is your dashboard. Whatever you need, that only you can keep as part of this one. So any chart, any new chart you build, you can add that to your dashboard so that with your dashboard you can monitor only what you need, not everything that by default you get for every service or for the cluster overall, right? So hope these things are clear to you. Probably in the coming session, we try to talk about the backup and the disaster recovery. So that part we'll be seeing in the coming session. Make sense, friends?